Good morning, everyone. Today we're going to learn about an important concept in computer networks called network topology. In simple way, network topology refers to the way in which computers and other devices are connected or in a way arranged inside a network. It describes both the physical layout, which means the cables or the physical devices, how they're connected, or the logical one, which shows the data flow or the way data flows in between these topologies. These both are really important as these help us choose the appropriate network topology, which helps us give better reliability and better way to implement a circuit. There are multiple types of topologies. The first one we're going to learn is mesh topology. In mesh topology, each and every device is connected to each and every other device. This sort of connection creates multiple paths for data transmission. Let's say we have to transmit data from device 1 to device 2. There are multiple ways. One is the direct way, one is the indirect way. And thus, this way you can transmit data through multiple paths. There are two types of meshes. One is a full mesh where each and every device is connected to each and every other device, such as this one. Or a partial mesh in which only some devices are connected to each other, but some of them have paths but not directly connected. Doing it this way has very huge benefits as this is very fault reliable and fault tolerant. As let's say this path, the current path fails, then we can use the other path to transmit data. Thus the data transmission never stops, and this is highly secure. But there are certain disadvantages of mesh topology. The first being that it is very expensive because there are a lot of cables required, and since there are multiple ways of transmitting the data, that many cables are required to implement this. Thus it's very expensive, and due to these many cables, the installation becomes very complex. The usage of mesh topology is very wide, as this being so reliant and secure, it's mostly used in high level military networks, banking, or stuff, or such businesses which can afford such high security or which require such high secure problems or solutions to such problems. And many and new types of meshes can also come which are wireless in nature, but this is most prominently used in highly secure areas where security is the highest concern, thus making this very appropriate for such uses. The second type of topology is called as bus topology. Inside bus topology, all the devices are connected through a single central cable, arbitrary cable called the bus. The bus is the backbone of this entire structure. This bus transmits data from, let's say, this device 1 to device 2. Device 1 sends the data through this cable to this bus. The bus transmits it to the intended location, that is here, since 2 needs to accept it. And once 2 gets it through the bus, the only way 2 can receive this data is through this bus. There are many advantages to this. That is, this is very cheap to implement. Like unlike in mesh topology, where from this 1 to this 2, there had been many cables. Like there had been one cable from 1 to 2, from 1 to 3, and let's say from 1 to 4. But here there is really less use of cables, which makes it very cost effective and very easy to implement. The disadvantage of this is while there are less cables required, but there is a single bus arbitration. So let's say one path fails, the entire thing fails, as there is no way of transmitting data from 1 to 2 without the bus being there. So this is a major flaw or disadvantage of bus topology, as this especially reduces reliability, which is the main reason why bus topology is not used nowadays, because there are more reliable methods to use rather than this one, where if a single part of the bus fails, the whole bus fails, and thus no data can be transmitted between any device to any device. The third type of topology is called ring topology. In ring topology, each device is connected to exactly two other devices, forming a circular ring type structure. Inside this structure, data travels in particularly one direction or sometimes in both directions around the ring until it reaches the destination. Let's say device 1 has data and it has to transfer it to device 3. So it can either go in this direction or in this direction, or in some cases both. This has many advantages and disadvantages, but disadvantages are more prominent. Advantages being the data flows in a very organized manner and there are no data collisions as there is two clear paths and thus there's no collision in between data. And the best one being that there's equal access for all the devices. But the major disadvantages of them being that the failure of either one of these devices can cause the whole network to break. And since all of these are connected in a ring type structure, it is very tough to add a device since each and every device is already connected to two. So adding or deleting becomes really tough, and any form of error or troubleshooting can become really tough because of each of these devices being connected in such a structure. Thus, removing a device to troubleshoot it becomes really complex. Thus, due to these major disadvantages, ring topology is not commonly used nowadays, but in older systems where token rings were used, at that time rings were used, but nowadays the usage has been stopped. The fourth type of topology is star topology, one of the most commonly used topologies nowadays. In star topology, all the devices are connected to one central hub called the hub or switch. The hub or switch is a central hub through which all the devices are individually connected. Each and every device has its own separate connection to the central device. Let's say there's one computer here and another computer here and a printer, which is a device which should be accessible to all of them, and another server, which should be a shared resource through this whole thing. So all of these are have their own individual private connection to the hub or the switch through a cable. And this makes sure that each and every one is not dependent on any other, unlike the previous ring topology, where if let's say a certain device fails, the whole circuit fails. This has many advantages. That is, it is very easy to install and manage because you don't need way too many cables. You just need minimal cables from the device to the hub. And even if one cable fails, only this device is affected. As let's say this particular workstation gets a fault, the entire network won't be affected, as workstation A, the printer and the server can work separately. And this makes it very easy to add devices, as you can just remove this cable and this device can be separated and another device can be added, and thus it makes it very easy to add more devices. Certain disadvantages of this system is that let's say the main hub or the switch fails, then the entire circuit fails. And due to this, there's a really high cost of setting this up. And due to all of these extra cable stress, this requires more cable than bus topology, and this has very wide uses, as this can be seen used in our colleges, schools, where there is a centralized server, etc., in our labs where there's a centralized server and that one server connects all the devices. So if the main server fails, all the devices fail. But if you want to remove a device or add device, it makes it very easy. The fifth topology is tree topology. Tree topology is a combination of star and bus topology. In tree topology, devices are usually arranged in a hierarchical type structure, wherein which is similar to branches of a tree where it gets its name. In this, multiple star networks are connected to a main backbone cable. The design starts at the top or the head, known as the parent node or the root. The root is the place where the branching initially starts. This branches down to levels and can further branch down to accommodate as many devices or peripherals as much as you can. The branching cable with no loop connects the root with all other nodes for communication. This has multiple advantages, the easiest one being that it's very easy to expand, as you can add computers here and here without disturbing the main system. And this is very suitable for large networks, as this branching allows you to take multiple computers and seamlessly run them without any issues, and this is especially good for large networks. But this has certain disadvantages being that if this particular backbone cable fails that starts from the parent node, the entire circuit tends to fail. And due to this, the installation and maintenance of a tree type structure can be expensive and cannot be affordable for most places. The usage is pretty diverse, as it is usually used in high-level universities and large organizations, and usually corporate or companies or multiple people use it. Now, let us discuss hybrid topology, which is one of the most important and widely used network topologies in current day and age. Hybrid topology is a type of network topology that is formed by combining two or more basic network topologies into a single network. Example, you can take a star network and combine it with a bus, which is the backbone of the bus, and make a hybrid network. When we connect different topologies such as these, the resulting network is called a hybrid topology. A star bus topology, as I said before, where several star networks are connected using a bus backbone, which helps reduce the disadvantages and increase the advantages. Such hybrid topologies are designed to take advantages or the strengths of different topologies while minimizing their weaknesses by using different topologies. How this works is that different parts of these networks use different topologies depending on their function and importance. In large offices, one department may use star topology, and these star topologies can be connected using a bus backbone, which makes it very easier for transmission and makes it very scalable and flexible. The main advantages of hybrid topology is that it's very flexible, as network designers can choose the best topology for each and every part of the system. Thus, it makes it very easier to expand, and new devices, new departments can be easily added. Thus, it's very reliable, and failure in any particular part of the topology does not mean the whole network would fail. Thus, it can be managed very efficiently, and it can be designed according to how the company or a person wants it to be designed. Thus, multiple topologies can be used. This in turn increases the cost, which is why I took the example of a large corporation, because small corporations can't afford such expensive stuff. Hybrid networks are usually expensive because they require hardware and cables and networking devices. Designing a hybrid topology is complicated and requires skilled network engineers, thus making it difficult for small scale companies or small scale usage of this. Troubleshooting hybrid networks is also not easy and can be challenging due to how complex this can become. Applications of hybrid topologies is usually limited, but is usually used in large organizations, universities, and huge data centers, which are very rare, but it's used. Why is it important in current day and age? Is because usually nowadays services have different need. Some services need high speed, some need high security, some need low cost. Thus hybrid allows us to use the advantages of certain while removing the disadvantages of certain by combining these topologies. Thus it is ideal in today's networking world. Why network topology matters. Choosing the right network topology is very important because it affects at how efficiently a network operates and how reliable it is. Network topology decides at how computers, servers, and other devices are connected and how data flows or transmits in between them. For example, inside a star topology, if one computer stops working, the rest of the network remains unbothered and can continue to function, which makes it the best suit for offices, schools, and small universities. This shows that network topology matters and making the right choice is very important. The choice of topology also affects performance and speed in a small network. In a simple technology like star, it works well as it allows fast data transfer. However, if we use a star topology for a very huge network, we have to compromise on speed due to congestion and slow performance. And let's say we use a mesh topology in critical systems such as banks. This ensures that even if a certain connection fails, data can still reach its destination. As in banks, security is the highest concern. And this is also a concern which is cost and future expansion, as not all network topologies are cheap. Example, hybrid topology is very expensive when compared to cheap network topologies such as bus, which is cheaper and which makes it easier for small scale applications. Thus, this shows that choosing the right topology helps balance cost with performance, which makes it easier to add new devices without redesigning the whole network. Thus, ensuring that we choose a right topology is important, as there are many factors that come into consideration while doing this. Thus, we need a topology which is best suited for us, which can be lower maintenance, easier troubleshooting, or a network which can always give you future needs, example, etc., etc. Thus, choosing a right network topology is very important. Now, as we've learned all of these topologies, it has finally come down to the important thing, that is choosing the right one for the right application. This depends on several factors. First being the size of the network. Example, if your network is very small, wherein you don't need much size or much scalability, a star or bus topology will be the best. While large networks like corporations or universities might use tree or hybrid topologies. Cost. Budget plays a very important role, as some topologies such as bus are very cheap to implement, while mesh topology is very expensive to implement. Reliability is also a very huge factor, as some topologies are heavily reliable like mesh or star, which even if one of them fails, it does not give much effect to the server. But if you if you need it for future expansion, you should use star, tree, or hybrid, which is way better in that. Maintenance and troubleshooting is also a very important factor, as constant maintenance can be a hassle, as star topology is very easier to manage compared to the others. Concluding all this, network topology defines how devices are connected in a certain network, and it plays a vital role in the performance, cost, and reliability. Thus, it should be chosen wisely. The right choice depends on the network size, purpose, budget, and reliability. Understanding network topology helps us design efficient and more better and reliable and scalable networks. Thus, it has to be right. Thank you.